presentation. RNP's recursive DNS increased performance, security, and compliance for the Brazilian academic network.
Good morning, everyone. I wanted to ask you to please adjust the stopwatch because I was given 15 minutes, but I prepared a 25-minute presentation. I'm Guillermo Roden. I work at RNP, that the national network that is our provider in Brazil. It's a 30-year-old company, and it was created to provide internet to universities. So this is the agenda of the presentation, and we are going to discuss these topics. First of all, we're going to talk about the DNS service that we have developed and implemented for our users, the organizations that use our services. So why is it that after 30 years, RNP decided to create a recursive DNS service for their users? Well, if we thought of this, for instance, a DNS is essential for the use of the internet from its very beginning. For more than 30, it was created over 30 years ago to facilitate the resolution of names for the IP addresses. So, as you know, DNS is essential for performance and internet security issues. Now, with regards performance, it is directly linked to the end user's experience. A DNS service may have a rapid response, and the user will have a good experience, how it was solved and how the browsing took place. But if it fails, the experience is going to be negative. So, and the network operators certainly may have had problems of customers claiming that it didn't have internet services, and actually it was all due to the DNS that was not working properly. And if we think of security, it may be used as a vector for malware, phishing, and other elements of this underworld. And so one of the motivations that led us to do this, and because we'd seen it in our network, is that many of our users are using public services, including Google, OpenDNS, Quad9, Cloudflare, so for their DNS resolution, instead of following the good resolution practices that would be having recursive DNS in the networks, and actually they end up using public services that may or may not be well positioned in the network. So as a consequence, we can see an increase in the time to response, the RTT, because there may be a service that is overloaded and it is beyond our control. There may also be a CDN that is not so close to the user, and also because of privacy issues, because it can have a negative impact on the user's privacy. In this slide, we see that we started with this in 2020. In late 2020, we conducted an analysis in one of the POPs in Santa Catarina, the state where I work in Brazil. And at the time, Google's DNS was the most important one. Then we had the Anycast DNS of RNP, and then the local DNS in Santa Catarina, where this service was created. So this is of the state of Santa Catarina. And then I'll show you the what was happening nationwide. We had Google in ranking first, and our services were far at the bottom. Many positions, many about the last in the ranking. Was in 2025, and we see that Santa Catarina is still more or less the same. We have public services such as Cloudflare and OpenDNS. Then there were some new ones that became more popular than in previous years, and now I'm showing you what happens nationwide, and the scenario is more or less the same. And the RNP service is gradually growing as we disseminate our services. Here, this is another data analysis. There is IPv4, IPv6 in the entire backbone. And an interesting thing is that the IPv6 traffic of DNS is very small, only 1 or 2% compared against IPv4. So let's see what this DNS service that we call DNS for education. It's a recursive Anycast DNS service. In this case, it's for education purposes. So it's under the RNP system that encompasses all the organizations that use our network, that are about 1,800 education centers, education and research tertiary level, that use our backbone at on a national level. Here you see the backbone of RNP in this map, multi-gigabytes, and we have several of 100 gigas in different pubs, and then we have some smaller ones, 1 to 3 or 6 gigas. Our country is huge, like a continent. And so what is the idea behind this? Well, what was the idea of disseminating this service through the backbone, through Anycast, with these copies localized in our different POPs for users? At present, this service is available in 9 out of all the ones that we have in the south, center, west of Brazil. What you see there in the map, some in the north and some in the northeast. And very quickly, I wanted to mention this slide so that you may see the idea of this DNS Anycast. Let's see this example. There we have a network user in Rio Grande do Sul that tries to have access to service to solve something. You may see these blue circles. There we have active services that are operational at present. A user sends an Anycast DNS query. It reaches the board router and it responds there. It will have a low resolution time and will find the best path. The user is close to my service. And then, in a second scenario that I'm bringing here, for some reason the Anycast service crashes, and when the request comes to that router, it will look for a routing table to try and find the closest router. See, here you see how it had crashed, and it goes to a neighbor one. There you see that latency increases a bit, but you see that it responded well. The user may have felt a short latency, but the service remains active. And here we have another example that is control chaos for those that operate this. Imagine this scenario. Here, almost all the services crashed, and there's only one clash. There's only one that is active. So when the user wants to access this service, the routing table would lead it to the closest router, and then it will forward it to the user. And for those who operate these internet services, you please know that Anycast is very interesting in this regard, because we can solve a crisis. We can have a calmer recovery of service without reaching the unavailability. Here we are going to see a worsening of the latency, but the services will remain operational. So let's see now. We created the service with these characteristics, and the key objective of the service is to offer a better usage experience for the IP network users. RedIP is the name of our RedIP is the name of our backbone, and we want it to be a high availability service. So there are many Anycast copies that are scattered all along our backbone, and we also included copies in all our POPs. And we wanted to have a low latency so that it will be closer to the end user, and we also use the local technique that makes it possible to use the root DNS copies and put them inside my DNS services, which enables me to increase the initial queries, avoiding trash. So if there's a machine that has a problem in the top level domain that isn't existent, it will remain in our server. It won't go beyond that. We also do the DNSSEC validation, and that is quite common at present. And in this service, we have also enabled RPZ. These are responsive areas, and we can realize DNS manipulation in some special cases, including, for instance, if there is a court mandate for blocking it, or if something it's propagating in the network and we can intervene. Our CSERT may do something about it. We also have logs, research logs with DNS tab because we belong to the academia. So we use it to get detailed abstracts of logs. And for legal purposes, we keep logs of our services and our customers. So, and we need to remember that this service is in conformity with the MCI and LGPD, the private data legal constraints. Well, and we also have an automated deployment. We use tools to make our life easier. Our services are monitored, and they're always being updated so to implement that in the backbone. In this figure, you see how we have created this service. I won't discuss it in detail, but the core of our environment is based on bind 9, that is a recursive DNS, and we use it in the cast infrastructure with the containers, and we have semaphore, we have Docker, and different statistics through Grafana and bind 9, among others. And today we have Ubuntu, and we are currently migrating to other systems. The idea is to have systems that can mutate and that may make the implementation easier. Here we have an image of how we have built that service, and it is based mostly on Docker. We have specialized containers, and we have an Anycast router, Anycast forward, and the recursive cache. The Anycast router is for BGP communication with our routers, and then Anycast forward is in the environment. Our Anycast addresses are raised with queries of the end users, and then we have the recursive cache that is responsible for resolving the internet domains. And Anycast forward has a level 1, and we'll address that to the recursive cache for it to get solved. So, and here we also have we can also do the monitoring. How do we use this in our infrastructure? We started with virtual machines. We use two. The initial one is going to run the 3 containers, and the second one with that we need to scale the service laterally. The more it grows, the more it can respond to the request. We have 3 layers, one for our services, and we have a layer for the microcluster with IGP among the containers, and there we will run the USPF.
We also have another interface, which is BGP, EGP. I'm going to run the session in EGP with a backbone. All that is in an Alpine image with Quagga, with bind and scripts, and Alpine Linux. This is on the Docker. So here we have an image of the infrastructure, 2 VMs with the network infrastructure. This is connected to the production box on the border, on the edge. And on the right, we have the routing structure, how we set this up. So my router, my virtual router, has a BGP session with a border router with a separate VMC, because with a private AS, because the other one is the backbone. Our users are connected beneath the border layer. So how did we do the automation of this flow? We have 3 environments: dev, test, and production. We're testing the solutions internally before we put them in the network. Then we have the testing environment, which is connected to the real routers. This is to test this prior we going into production, and then we go to the production stage where we have the containers. We have 2 projects in the laboratory. One is RNP that has to do with automation, and this is so that the Ansible can do the configuration of the entire environment. And the other Git lab is for the same project. So how do we set up the DNS Anycast service? Today we use the traffic light, but for the purpose of simplifying the tasks, we use that tool. These are some of the statistics that I want to share with you. We put the bind. We use the API of bind with Telegraph. We can see the results on a regular basis. We include that here we have Grafana, and if we look at the use statistics, a large number of the users are in the southern part of Brazil and end up reaching the capital city of Brazil. This shows the concentration of the users of our services today. Here we can see the user experiences with our services. This is analysis of the DNS resolution and round time of the POPs in the south of the country. In orange, we have the POP of the south of Brazil. This is one that is very well connected. This POP has several CDNs. We conducted tests with cloud solutions, OpenDNS, and Google and others. So if we have a look at the case of Rio Grande do Sul, the south of Brazil, and the different options and the resolver, everything had yielded very similar results, both for our RNP services and the public services. Santa Catarina is the state that is next to the state of Rio Grande do Sul. We don't have CDN services in that IXP, not even in the backbone of RNP, which is a POP that we have in Santa Catarina. So the delay was a bit higher, 4 to 10 milliseconds, but the end user nevertheless has an interesting experience using this. The resolution in the last part shows that our service provides quite a rapid solution, but the content is somewhat far away, so the users have to go further away to find it. Over here we have like an extreme situation. I'm no longer in the south of Brazil. I tested this in the north and northeast region of Brazil. So this is beyond the equator. So if we look at this case over here, for the DNS service of RNP, which we see in red, the resolution time was very fast. The cache is there, but the content, however, is far away in a different location. This is in Sao Paulo, probably. So if we have a look at this, this leads us to analyze the great advantage of the service. DNS resolution was very fast. This is regarding the query that was done. However, the Anycast is very far away. Therefore, the user experience is better in terms of resolution, but the content are very far away. So we have to continue working on this. However, at least the DNS part has been solved, and that would be the first point. In addition to that, we included in this service the bind version field, version.bind, as well as the Anycast points that have been resolved. I can do a query to check what content is being delivered. So this is work we have in the pipeline. There is an increase in the privacy of transport. Last year, we validated the issue of DOT and DNH, DNS over TLS, and DNS over HTTPS, so users have more privacy regarding transport. This year, we're going to be deploying this. We are also entrusted with the development of an authoritative service. This is now a recursive service. The idea was to facilitate the delivery to our users. We also work with premium security protection. We are also conducting research in this regard. And we have also increased the mesh. We have some issues with the POPs. We have to standardize the devices. We do have to change some of the devices in our backbone. And this also requires investment. The intention is to have 27 POPs. So we're conducting research to take this service inside the CPE in the final destination. So this is what I had to share with you today. I thank LACNIC very much for the opportunity to make this presentation, and also our team of Edu DNS RNP, who have been working on this project for many years and considering to implement this project. Thank you.
Esta es una pregunta.
We have a remote question from Ernesto Pérez Esteves. He's asking the following regarding the kindness service. Did you know about previous experiences in the region? The DNS. In an event of IX Forum, the people from ICANN, they made a presentation on this service, and we started working on this initiative with shared. This is KIN DNS. Hugo Salgado from LACNOG. First of all, congratulations on this amazing job of world quality. I have seen developments of DNS Anycast services, but this really clearly shows all the features that might expect. And this is a great presentation. There were many doubts that came up along the way, but I saw that you weren't explaining these as you went along. Could you please explain what is the administrative burden of managing a recursive? There is this myth that there is a lot of day-to-day work involving exceptions for certain sites. We all know that there are certain authoritative DNS servers that don't behave well, and it is thought that the recursive should always be making exceptions, and this is quite a tedious task. Now, what is your experience in this regard? That is a great question, and I had considered including that in my presentation. This is a service that involves quite a low dedication in terms of support. For the 4 to 5 years that we have been working on this, we have had calls from 4 to 5 calls every year. What are the types of problems did we come across in our day-to-day work? First of all, through the DNSSEC, we had issues. So the response wasn't very good. And then some of the DNS services, like you mentioned, the person signs with DNSSEC and puts a TTL of 1 second. So there is not enough time to do all the cache, and so that cache get used to this and does the resolution. So in this case, we used the available contours so this wouldn't happen again. But this is a service that, for us, operates very well. Congratulations, Guillermo, on your presentation. Let me just correct something. I didn't introduce myself in the first question. I'm Henry Godoy from the State University of Campinas, UNICAMP. Congratulations on your project. Very interesting. I would like to say that this project, when you shared the IPv6 statistics, beyond the fact that these are somewhat timid, when we deliver a dual stack service, communication sometimes occurs through DNS in IPv4 and not in IPv6. Sometimes we don't deliver IPv6 as DNS, and the preference ends up being IPv4. But I think this will change over time. The closer the DNS is to the user, then the better it is. Now, there's a question that I forgot to ask. is this service exclusively for the clients of the RNP network, or can anyone else use the recursive DNS in your home address or at university or at your job? Thank you. Well, that's a great question. To add on regarding the IPv6 and DNS, we have very little traffic, very, very timid, as you said. So it is very meaningful. Like you said, we prefer to use DNS. They prefer to use DNS and IPv4. And what was the next question? Regarding the use, where this is exclusively limited to the RNP network.
The use of this recursive is for our users. That is, all the clients that we provide internet transit to can use this service in the community, in the world. Well, they don't have access. Thank you. Congratulations. So, Julia of the Federal University. Now, I didn't quite understand this authoritative that you're going to build. Is that right? Because the aim was to provide service to institutions. Yes. What we intend to do is to improve the usage experience of our users in DNS resolution. There are many institutions that use public DNSs instead of having their own DNS internally close to the user. That is why we created this service, to improve the experience of end users in those resolutions. And won't it lead to competition, competing against NECBR DNS that was very well put together at the registry? I'm sorry, but I can't hear you well. I wanted to know whether maybe this authoritative DNS would not be competing against the DNS of NECBR. No, actually, the authoritative, well, this is for the Federal University, so that instead of having a copy of the authoritative, well, you may have a master with the registry of the area, and we're going to give slave DNS so that the customers may have a better availability among its services. Actually, we won't compete with the BR registry, because we are trying to give a better DNS service to the institutions. Thank you.